and we're talking about graphs of functions. First thing I want to talk about then is the best way to accurately sketch a graph on your paper. Wrong way to do this is to just go in and say, well, it kind of looks like this. No. What you want to do is once you get a graph, go into your table, and the first thing you want to do is make a table of values that covers all of the important parts of the graph. And we'll talk about what those look like, but you should be able to look at it. It's where the graph is changing. Then you plot the points. Accurately. And write down your scale. Scales X and Y on your plot. And then the last thing is to connect the dots. But what you do by making a table of values and then plotting those points is you're actually going to make an accurate graph rather than one which sort of looks kind of like it. Let's take a look at what this might look like, and let's pull up Grapher. Okay, so let's deal with the function x cubed minus 8. All right, so where are the interesting parts of our function? Now, obviously, you'll have this on your graphing copy to make it a table. Well, if you take a look at it, really between here and here, no, not a whole lot is happening. So you might want to pick up maybe 1 or 2 points here, but not a whole lot going on. All right, now when we come in down in here, you notice that there's a whole lot going on. Now, this is a good point to get because this is an x-intercept. X-intercepts are always good points to find. So you want to get several points from right in here. And you want to make sure and get your y-intercept. Okay, same thing as you come down here, you notice that it is just kind of going along, so you get a couple of points. When you come along on your paper, once you get these points, then you draw your graph, put your scale. This is 2, 4, 6, 8, 2, 4, 6, 8. And I know that at -8, I've got a y-intercept. And I've got an x-intercept at 2. And I've got some points in here. I know that it's doing some rather fascinating things around here. But once I get these points, I can plot these, and then I can plot these off. Now, you should actually have some points graphed up here that I skipped when I went through this stuff. Okay, so now let's talk about what we do then. If we've got a piecewise function. Remember, piecewise function has got different functions on different parts of the domain. I already talked about this a little bit. It's going to equal -1 if. And this tells you the domain. X is less than -1. It's going to equal to 1 if x is between or equal to -1 and 1. And then equal to -1 if x is just strictly greater than -1. Okay, so what I do here, when I take a look at this, I start at the top, which in this case also happens to be the left side of the graph. These are the numbers which are the smallest. So start on the left of your domain. And normally that's the way these things will be written piecewise, is I'll start with the left part of the domain. So the first thing I'm going to do then is put my graph up. -1. I'm labeling it. You better label yours. Notice my f of x then is going to go between 1 and -1. Do not assume I know just because you have one hash mark that it's 1. Label the thing. Okay. So now let's come and look at this guy. So if x is less than -1, I'm going to be -1. But I don't include it. So that will look like this. And the circle is open because I do not have the equal sign down here. So anytime my x is less than -1, which is over here, my f of x is going to be a -1. All right, so that's done. Now let's come down and do the next one. And here I'm looking at 1, which is up here. So I'm looking at something off like this. But it's 1 if it's between -1 and 1, including those points. I'm going to go to -1, go up to 1, plot my point, and color it in. I'm going to go up to 1, 1, plot my point, and color it in. And I know that between those two values, it's equal to 1. Okay, been there, done that. And we do the last one. This is where x is bigger than, shoot, that should be 1. X is strictly bigger than 1. And I know it's going to be -1, so it's going to be back down here. So I go in, I plot a point, but I don't color it in because it's not equal to it. And it's going to be -1 for all points out here. And this is what that piecewise function looks like. And again, it's the same thing. You just do one piece at a time. Okay, domain and range from a graph. Okay, so let's come in, and I'm going to pull grapher back up again. I'm going to change my function a little bit. Instead of dealing with this one, I'm going to have y equals to the square root of 16 minus x squared. All right, and let's zoom in on this a little bit. Whoa, too much. Okay, here we go. Domain. So here's where we come in and take a look at. Domain, you're just looking at x values. My function or my graph, you notice, only exists between this point and this point. Out here, no graph means not in domain. Out here, no graph, not in domain. Oh, I'm off of where I'm recording. So we come in and take a look. This is negative 2.5, 3, 3.5. That's negative 4, and that is 4. So my domain then, when you start on the left side, is going to be negative 4. That will be smaller. It's included in it, x. But x is going to be less than 4 over here. Okay? And so now we make the same argument, but we ignore the x values, and we just look at what's going on with the y values. Okay, so when I come in and take a look, no graph. Anywhere. No graph means not in range. Between here and here, I have a graph. That means it's in range. Above here, no graph. Not in range. Okay, so now we come and take a look, and for our range, we do the same kind of thing. The smallest y value I have is 0. It does touch it. The biggest y value I have is 4, and it touches it. So that's the range of this function. Look for where the graph is. You look for where the graph is not. Where the graph is not, it's not in range. Where the graph is, it is in range. Okay. Let's do another example here. X minus 1. Alright, you should be able to graph this guy by hand, but let's take a look at our graph. And then zoom out and take a look at a really big honking picture. And I want to look at some really big numbers out here. Okay. So we want to deal with domain first. I come out here and I notice as I continue to zoom out and zoom out, everything out here is still in range. And I mean everything. No matter how big I get, it's still going to be in the range. So that is going to include all negative x values. All right, I do have x at 0. And notice the same thing out here. All, not in the range, domain. All are in domain. So in other words, all of my positive values. So now we step back and take a look. All my negative values are here. 0 is here. All of my positive values are here. What that means is my domain is all real numbers. You could also write it as, they're the same thing. Okay, so now let's back off. We're done with the x. And let's take a look at our y values. Same idea here, only I'm looking at y. So I'm going to start down below. Again, the same idea. No matter where I go and how big my y values get down here, everything is in the range. Where I've got all negative values. All right, 0y is in there also. And then I come back and I take a look at my positive y's and the same thing. I've got all positive y values. So my range for this is all real numbers, or either way you want to do it. Okay, I want to do another one here. Let's take a look at it, because this one's it is very different. But it's something you're going to have to learn how to master in this class. And with this one, I want to deal with the square root of x minus 1. All right, so here we go. And we're looking over here. I'm going to zoom in on this thing. Okay. So now each one of these is 0.5. Again, let's deal with domain. It's always a good place to start, which is your x values. I notice out this way, no graph, not in domain. So if you take the coward's way out and write all real numbers, you've done me a favor, I'll give you no points for it. Now look out here, I have graph. Forever. All are in my domain. Okay, so what we want to do then is deal with the leftmost value, where I've got it, and that is 1. And it's included. And then I notice it keeps going forever, so it's infinity. That's one way to do it. Or you can also write this as x has to be bigger than or equal to 1. All right, so now let's back around and take a look at range. Okay, I'm going to erase all this mess because we've been there, done that. I want to do the same thing by looking just at my y values. So I'm going to start with my x-axis, look below that, and I notice no graph down below here. For negative y values, no graph, not in range. Here I've got a graph. Forever, it keeps going. So that's all in range. So again, I notice from 0. So my range, I can write this as 0, which will be greater than or equal to my y, which will be less than infinity, or y is greater than or equal to 0. And that's how you get your domain and range on this thing. The last thing then before we go, let's take a look then about how do you figure out if an equation is a function. Is this a function? And you're thinking, yeah, we learned how to do this in Algebra 1. Yeah, you did, but I learned not to take care of, not to count on it. So the first thing you do is put your equation into AY equals form. Or you can put it into grapher, either way. Graph that puppy. And then 3. See if it passes VL2. Okay, so let's take a look at a couple. I've got x equals y squared. So I'm going to use symmetry to rewrite that as y squared equals x. But this is not in y equals, I have to take the square root. So y then will be equal to plus or minus the square root of x. I can tell you right now, this will not be a function because for each value of x, I can get both a plus y and a negative y. That's not a function. But let's come back in and actually graph what we got. And let's come back in and take a look at grapher. And how it does it. Now you can graph what you had already in, or the form you had in the TI-84s. Well, let's graph the original guy, and I have not tried this yet. I hope they haven't messed this up. Where I had x equals y squared. Oh, good, they have it. All right, so here we go. We've got our graph. Now you notice we didn't even solve it. Now you go in and see this passes the vertical line test. No, this poor puppy is not a function. It's just a relation. So let's take a look at another one. X equals to y cubed. All right, well this is different. And you'd be tempted at this point to say, okay, well, let's see what we got. It fails it here. Be careful. Zoom in on this before you look in at it. Let's keep zooming in on it. And you will see what's happening is that as we come down, this is getting very close to here. But it doesn't actually cover 0 here, and then it comes back around over here. It's very close to it, but it's not at it. So this thing does not fail the vertical line test. So this is actually a function. And we can do that algebraically too while I'm thinking about it. So I have x equals y cubed equals x. Y equals the cube root of x. Now because this is odd, we can get both plus and minus values out of this x, and that's all right. Okay? So I could put a -8 in here, and my cube root of -8 would be -2. Cube root of 8 would be 2. So this tells me, just algebraically, because it's an odd root, and you can write that as x to the 1/3, by the way. You should get used to doing that. And because it is, it tells me that this is indeed a function, which is also what we got from the graph.